A 7-gram bullet shot straight up in the air with an initial speed of 2 meters per second and reaches a height of 900 meters. And we are asked to calculate the average force of air resistance acting on the bullet. So I'm going to start by visualizing the problem. I'm going to identify the initial state and final state. Initial state is when the height level is equal to 0. So y coordinate, initial y position is 0, final y position is 900 meters because the bullet is going to reach 900 meters above the initial height level. Then it's going to slow down and finally it will reach the final point. Final position. Initial velocity is 200 meters per second. It's given in the question. And final velocity is 0 because that is the maximum height bullet can reach. That is the turning point. At that point, final velocity is equal to 0. And let's draw a free body diagram for the bullet. I'm going to start by defining the coordinates. I'm going to take up as positive y. And in the free body diagram, we have to show the weight of the bullet acting directly downwards, and then we have the force of air resistance acting directly downwards because air resistance opposes the motion. So if the bullet is moving up, force of air resistance should act downwards. And then work diagram, and in the work diagram, so in this course, we talk about two conservative forces, weight and the spring force. All the other forces are non-conservative forces. So here we have the force from the air resistance, and it's directly downwards. The position or the displacement vector is directly upwards. So the angle between the air resistance and the displacement vector is 180 degrees. And the mass of the bullet is 7 grams. I'm going to convert it to kilograms. That is the standard unit, 0.007 kilograms. Okay, so now we identify the knowns and unknowns. We have visualized the problem. Let's see the applicable concept. We have to use the conservation of energy in this question, and let's see how we are going to use our conservation of energy equation. And this is chapter 7 in your textbook. Coordinate system is specified. We have taken up as positive, and we are trying to calculate the average force of air resistance. And the unit is newtons, and we expect a negative sign based on our coordinate system. Let's plan the solution now. So I'm going to start by writing down the conservation of energy equation. Potential energy initial potential energy plus initial kinetic energy plus work done by non-conservative forces is equal to final potential energy plus final kinetic energy. So initial potential energy of the system, that would be just 0 because the height level, initial height level is 0 as you can see in the diagram. And kinetic energy finally is 0 because that's the turning point. The kinetic energy will become a 0 at that point because the velocity is 0. And so now we have just 3 terms in our conservation of energy equation. And work non-conservative is equal to force of air resistance times the distance, the magnitude of the displacement times cosine of 180 degrees. Now let's execute the plan. So initial kinetic energy plus work done by non-conservative forces is equal to final potential energy of the system, half times mass times initial speed squared. So remember this V is the speed plus force of air resistance times d times cosine 180 is equal to final potential energy. So it's just mass times g times 9, g is 9.8 times height final. Okay, so now let's see. Mass is 0.007 kilograms and initial speed is 200 meters per second, and you have to square it plus force of air resistance. This is the average force of air resistance. We don't know that yet. That's what we're trying to solve for, times 900 meters times cosine 180 is equal to -1 is equal to mass times 9.8 meters per second squared times the final height, which is equal to 900 meters. Just wanted to make a note here. You can choose either the initial state or the final state as your h is equal to 0 level. In general, we choose the lowest level of the two as the height is equal to 0 level. So 140 kilogram meters squared per second squared minus 900 meters times the force of air resistance is equal to 61.74 kilogram meter squared divided by second squared. And then I'm going to separate out the average force of air resistance, and I'm going to solve for it. And once I solve for it, I get 0.087 newtons. So this is the magnitude of the average force of air resistance, and 1 Newton is equal to 1 kilogram meters second squared. So that means you get the answer in newtons, and this force is acting in downward direction. Okay. So is the solution complete? Yes, the solution is complete. We solved for the force of air resistance, and everything else looks good. We did every step. So now let's see the energy chart. So initially there's a kinetic energy. This is not drawn into scale. Let's assume it's just 3 units. And initial potential energy, gravitational and spring potential energy is just 0. Work non-conservative is negative, and let's assume it's just 1 negative unit. And there's no final kinetic energy. Potential energy is 3 minus 1 because initial energy of the system should be equal to final energy.